Hello and welcome to our video solutions for Quiz 3 from our Spring 21 Math 258, which is Calculus 3 class. In this first video, we're going to be finding the global max and min of a reasonably simple function. It's k of xy is equal to xy. And we're told it's given on a triangular domain bounded by these 3 points. So why don't we draw a picture of what it is we're looking at. So let's see here. So we have the point 0, 0. There we go. And then we go to 2, 0. And then 0, 2. And we want a triangular region bounded by these 3 points. So we can connect up these dots. All right. Now, we know for using for finding the global max and min, eventually we want to use the extreme value theorem. And when we use the extreme value theorem, at some point we're going to want to check the boundary of this curve, right, which is going to be the outside region. And when we check the boundary of this domain, we're going to be needing to check also the boundary of each side of the domain. So like the very first thing I always do in a problem like this is just work out the values at the corners. All right? It's not always going to give you your max or your min, but you're almost always going to need to know those values, right? And by almost, I mean always. So for example, here at 2, 0, well, when I make, or rather 0, 2, when I make x equal to 0, the product will be 0. So this point here gets a 0. And when I check 0, 0, well, both x and y are 0. So I get a value of 0. And when I check 2, 0, well, now the y coordinate is 0. And so I get a 0. So the value at all 3 of the corners is actually 0. All right, fine. What do we got to do? Well, the extreme value theorem says you have to check the critical points, and then you need to check the boundary. So let's get the critical points. So we find the critical points by computing the gradient of k and determining where the gradient is 0. So let's compute the gradient of k and set it equal to the 0 vector. So the gradient of k, we need to take the partial derivative with respect to x. So I need kx, and then the partial with respect to y. So the partial with respect to x is just y. The partial with respect to y, now I'm treating x as a constant. Okay, we just get x. And so where is this equal to the 0 vector? Well, only when x is 0 and y is 0. So the only critical point is 0, 0. Hey, and we've already determined the value at that critical point. Cool. So check. Now we need to check the boundary. All right, so those are these 3 different lines. So we could label these 1, 2, and how about 3? All right, well, something is really nice in this problem. If we are lying on the y-axis, then we know that the x-coordinate is going to be 0, which means when I evaluate k on the y-axis, I'm always going to be multiplying 0 by the y value. Well, then it doesn't matter what the y value is, does it? So if I evaluate k along I, this is just going to be 0 times y, which is 0. So in fact, not only do we get zeros on the corners, we get 0 everywhere, up and down this line. And similarly, if I evaluate k along line 2, well, now the y coordinate is 0. So this is always going to be x times 0, which is 0. So I get 0 everywhere along the bottom boundary as well. All right, so the only thing left is this line 3, this diagonal line. And so it's going to be useful to write down what points on this line look like. And we can do that by writing down the equation of this line. Now, since it goes from 0, 2 to 2, 0, the slope of this line is -1, right? It goes down by 2 and it goes over by 2. Okay, so we can write y equals -x. And then we need the y-intercept, which we can see clearly is 2. Okay, so every point on this line segment looks like some x-coordinate, and then the y-coordinate is negative x plus 2. Let's evaluate k along line segment 3. So here it's x times y, but now the y I can replace by negative x plus 2. Okay, well, I'm curious where I'm going to have the largest and the smallest values along this line segment. And so I need to find the largest and smallest values of this function. All right. Well, there's a couple ways I could do that. Let me show you both ways. So the first way is I like it better in this situation just because we know we have a parabola, right? If you distributed this, you'd have negative x squared plus 2x. But you also know how to use the symmetry of the parabola here. So for example, when x is 0, this product will be 0. When x is equal to 2, this product will also be 0. Right? Of course, we had that from up above as well. Okay, but that means you have, and by the way, this is a downward facing parabola because of this negative, right? The leading term would be negative x squared. And so the parabola is going to look something like this. Okay, the question is where is this high point now, right? Where is this vertex? Well, because of the symmetry of the parabola, you know it's right down the middle between 0 and 2. So that actually has to occur when x is equal to 1. Alternatively, we can find the max by taking a derivative. So we could take the derivative and, okay, let's distribute this so it's easier. The derivative will be negative 2x plus 2. We're trying to find a critical point of a single variable function, so we set it equal to 0. And of course, solving this equation, we get x is equal to 1, right? The same answer we got over here. So in either way, we find that along this curve 3, we're going to get a max value smack down the middle at 1. Okay, well, maybe that's not quite smack down, is it? There we go. Okay, well, now we just need to know what the actual value of the function is here. So let's see, what is the coordinate? So x is 1. And then y is going to be, well, let's see, negative 1 plus 2, which is also 1. Okay, and we can evaluate k at that point. So what is k of 1, 1? Well, it's 1 times 1, which is 1. So we actually get here our value being 1. So all along the boundary, everywhere along, or at least along the left and the bottom, it's 0. But along this boundary, okay, it's going to be increasing, starting from here up to the middle, but then it'll start decreasing, right? So it's, again, if you like, it's increasing from this corner up to the 1, right? So you'll get all these values between 0 and 1. All right, and so this point here will be our maximum, and the minimum is going to occur all along this boundary. So global max is 1 occurring at 1, 1. What about the global min? So the global min is 0, and it occurs along the x and y axes. Okay, we have found our global extrema.